So in this lesson, we're going to focus on how to deal with figures in the coordinate plane and do some coordinate proofs, which are going to basically be like that problem that we did way back on the notes on SAS and SSS when we were looking at proving triangles congruent using your distance formula, etc. Okay, so if we take a look at the first example, what we want to do is we want to make sure we can position figures in the coordinate plane so that way we can work with them using specific points. And what's neat about this is you have the option to choose where you want to center one of your vertices. So for example, in example 1, I want to position a rectangle with length 6 and width 4. So that'd be, something like this, 6 and 4. But because we want to deal with the coordinate plane, I want to take each of these corners and make them a point on the grid. And we can either put a corner at 0, 0, for example, and then count out your units. So here's my first vertex, then I'm going to go 6 on the X, then I'm going to go up 4 on the Y, and then just find that last spot, which will be 6, 4, and there's my rectangle that has a length of 6 and a width of 4. Now I don't always have to put the one corner on 0, 0. I can, for example, use the oops, I switched this around, so let me just redo that. So I can this is using the origin as a vertex. We can center it at the origin, meaning let's put the middle of a side at 0, 0. So for example, if I want the bottom, right, to be centered at 0, 0, I might take that 6 divided by 3 and just go 3 to the left and then 3 to the right. And this is still, 6 units, right? Just like this one was 6 units. And then from there, same deal, right? I'm just going to go up 4, from the other vertex, and this should create my rectangle. So it's the exact same rectangle, just translated over to the left, right? So instead of using the origin as a vertex like I did over here, I'm centering it. And I still have a length of 6 and a width of 4, right? So same thing here, width of 4. So that's where you have some freedom to move your shapes around, and some people might even want to center completely at 0, 0, so moving this down 2 to put the whole center of the figure at 0, 0, and that's something you can think about as well. So again, it depends on what you want to do with the figure. For our purposes, I'm going to mostly use the origin as a vertex because I think that makes the points a little bit easier to use, especially considering distance formula and things like that, but again, it's up to preference. So if you take a look at the next example, we're going to do a little proof here. So we want to take the right triangle that we're given, the fact that D is the midpoint of AC, and then prove that the triangle ABD has an area that's 1/2 of the triangle ABC. So it might help to actually plot out the points. So I'm going to count each of these as a unit of 1. So I'm going to go 0, 0 for B, and then 0, 6 for A, and then 4, 0 for C. That's the given right triangle. Okay? Then we know D is the midpoint of AC, and then we want to find the area. So when we're doing our coordinate proofs, we want to consider using formulas. Let me scoot up a little bit. And remember we talked about this before. We considered the slope formula. We also talked about the distance formula. But we can also do other things like the midpoint formula. And because we're dealing with shapes here, we can also have our area formulas. which change based on the shape, right? And then the idea of perimeter. And you'll want to reference these formulas as you're using them in your coordinate proof, kind of like what we were doing before. So I'm okay if you don't do this in a 2-column proof. I personally prefer a paragraph type proof here, but what's important is you show me all your work. So since we're not actually given the coordinates of D, right, I'm going to start with my midpoint formula. And then just show my work. So the coordinates of D would be x1 plus x2, so 0 plus 4 over 2, and then y1 plus y2 over 2. So the coordinates of D are 2, 3. And I'm going to go ahead and plot that on my coordinate plane so I can work with this. So there's my D, and then I want to create the triangle ABD. So I'm going to connect B to D. There's the second triangle. Okay? Then I can just basically count the length . Because when I'm dealing with area, remember area is 1/2 base times height. By counting the lengths on the graph, I know that for the larger triangle, AB and BC are that perpendicular side, so that's my right angle. So I want AB to be my height and BC to be my base. So I can count and say, well, AB is 6 units, BC is 4 units, and that's for that larger triangle. For the smaller triangle ABD, you might think, well, wait, where is that right angle? Well, consider taking D all the way down to AB, and isn't that a right angle right there because it's horizontal and vertical? So that makes AB the base, and then this little light blue segment the height. So for the other triangle, I need to find the height of triangle ABD. And if you want to add another point there and name it, that's fine. But then I just have to count out that too. Okay? And then we know the area formula. I'm going to keep scooting this up. For a triangle, A equals 1/2 base times height, the area of triangle ABC is 1/2 of 6 times 4, which is going to give me 12 square units, and the area of triangle ABD is 1/2 of, remember the base is again AB, and then the height is 2, so 1/2 of 6 times 2, which is 6 square units. And then, since 1/2 of 12 is equal to 6, the area of triangle ABD is 1/2 the area of triangle ABC, which is what we were trying to prove. So it's just, you know, writing your work kind of in an orderly way and using formulas that we know. Okay, we're going to do the backside in class when we kind of take it away from the grid and look at just general points and then talk about the proof in class. Please come back with questions, and remember, if you want to think about the test coming up, maybe putting some of these coordinate formulas, midpoint, distance, area, would help. All right, thanks for listening.